My dear students, now today we are going to solve the remaining problems in the exercise 7.1. Question number 6 is, a stone is dropped into a pond causing ripples in the concentric circle. The radius r of the outer ripple is increasing at 2 centimeter per second. So 2 centimeter per second. That means dr by dt is given, rate of change of the radius is given. Okay. When the radius is 5 centimeter, find the rate of changing of the total area of the disturbed water. So that is the question. So here it forms a circular ripples. So area of the circle is nothing but pi r square. Okay, let me consider, let A be the area at any time small t. Okay, so A equal to here pi r square. A circle means pi r square. So differentiating with respect to t, dA by dt equal to pi is a constant. So r square differentiation 2r. So 2 pi r into dr by dt. So here r is given as 5 and dr by dt is given as 2. So put it here. So for 2 pi into, what is that, r, 5 into 2. So totally 10 into 2, 20 pi. Here unit is centimeters square per second. It is the rate of change of area, dA by dt. Number 7 in the exercise 7.1. A beacon makes one revolution every 10 seconds. It is located on a ship which is anchored 5 km from a side shoreline. How fast is the beacon moving along the shoreline when makes an angle 45 with the shore? My dear student, so there is a term beacon. So beacon means it is a signal light. Imagine like a lighthouse. So it is a signal light, but it is fixed on this ship which is anchored on the sea. Okay. So here we have to draw the diagram, then only we can easily understand the problem. So my dear student, assume it is the seashore. Okay, and it may be the sea. So ship is maybe anchored here. So beacon is there. It is revolving. Okay. So one complete rotation it took 10 seconds. So already we know that one complete revolution means 360 degree. So it took 10 seconds for 360 degree. So for 1 second the revolution, what is the revolution means 2 pi by 10. So pi by 5, it is nothing but change of angle d theta by dt. So keep this value. And once again come to the problem. So it is the seashore, it is anchored here. So look at that. So it is the projection of the light. So it get, imagine here, so light may be so reaching the seashore like this. So it is like a movement of the arm in the clock. So imagine the movement of the angle in the clock. So the light is moving like this. Okay. So I assume that it is the distance between the ship and the seashore. It is given as 5 kilometer. Okay. And given that this is the light ray. So this angle is given as 45 degree. Okay. So now look at here. We get a right angle triangle. Okay. So this is 5 and this distance is not known to us. We can take it as x. Okay. So look at the diagram. What comes to our mind? Opposite side by hypotenuse. So tan theta. So tan theta equal to opposite side by hypotenuse, that is x by 5. Okay. And also theta is 45 degree. So tan 45 equal to x by 5. So keep this as 1. So already we know that tan 45 is 1. So which is equal to 1. So x equal to 5. Keep this value. Okay. So what is asked in the problem? How fast the beacon moving along the shoreline when makes an angle 45 they are asking dx by dt. So they are asking dx by dt. So from the equation 1 implies what we get? X equal to 5 tan theta. So in the problem they are asking dx by dt. So differentiating with respect to t. So dx by dt equal to 5 is a constant. Differentiation of tan theta is secant square theta, and differentiation of theta is d theta by dt. So with respect to t, again we know that theta is 45 degree, and already we found what is d theta by dt, pi by 5. So put the values here. So secant 45 the whole square into pi by 5. Okay. Now put the values. Secant 45 is root 2 the whole, 5 cancel, root 2 the whole square into pi. So 2 pi. So the unit is kilometer per second. Okay, that is the answer. Question number 8 in the exercise 7.1. The question is, a conical water tank with vertex down of a 12-meter height has a radius of 5 meters at the top. So look at here. So look at the inverted conical shape. So it is the radius and it is the height. Given that r equal to 5 and h equal to 12 initially. Okay. So if water flows into the tank at the rate of 10 cubic meter per minute. Okay. So dV, rate of change of volume. Water flow means it is nothing but rate of change of volume. dV by dt is given as in that question 10 meter cube per minute. So it is given. How fast is the depth of the water increases when the water is 8 meters deep? So the question is, when h equal to 8, so what is dh by dt? That is the question. Okay. So I think all you know the formula for the volume of the cone. So volume of the cone, V equal to 1 by 3 by r square h. 1 by 3 by r square h. My dear student, here we are involving only volume and the height. So we have to replace this r in terms of h. Already we have, okay, h by r equal to 12 by 5. H by r equal to 12 by 5. Okay. So sorry, r you can find out r by h. R by h equal to 5 by 12. So r equal to 5 by 12 into h. So replace it here. So 1 by 3 pi 5 by 12 the whole square into h. Sorry, 5 by 12 h the whole square into h. So look at here. No need to multiply this 3. Keep is as itself. So 5 square is 25. 12 square is 144 into h cube. Okay. So don't multiply with the 3. Okay. Now our aim is to find out dh by dt. So differentiating with respect to t. So dv by dt equal to 1 by 3 pi 25 by 144. Differentiation of h cube is 3h square into dh by dt. So this 3 cancel. Okay. So already given that values are given, dv by dt is 10 and h equal to 8. So put the values here. So 10 equal to pi into 25 by 144. Okay. So into what is that? 8 into 8 into dh by dt. Okay. 8 into 8 into dh by dt. So if you want we can cancel. So 2 5s and 5 5s are 25. Okay. And 1 2 here 4. Okay. So if you want we can cancel by the 4 into, so if you want we can cancel by 4 one time, okay, 3 times and 6 times, 188 and 4 8s are. So here we can cancel by these two, not 8, we can cancel by I think 4, so 2 4s and here 9, okay. So now what are the remaining? So 5 into 2 10, 10 by 9, so 10 pi by 9, okay. So 10 pi by 9 dh by dt equal to 1. We need only dh by dt, okay, just to cross multiply. So dh by dt equal to 9 by 9 pi 10 pi. So what is the unit? Meter per minute. Meter per minute. Okay, question number 9 in the exercise 7.1. The question is, a ladder of 17 meter long is leaning against the wall. The base of the ladder is pulled away from the wall at the rate of 5 meter per second when the base of the ladder is 8 meter from the wall. So look at here. Initially the distance between the base and the wall is given as, okay, 8, okay, and if we assume let x and y be the horizontal and vertical movements of the ladder, so distance between the bottom of the ladder and the wall is considered as x and the top of the ladder and the floor is y, okay. So initially they are given dx by dt equal to 5. So it is given 5 meter per second, okay, and x equal to 8 and the length of the ladder, if you consider AB as the ladder, it is 17 is given. There are two subdivisions. The first subdivision, how fast is the top of the ladder moving down the wall? They are asking dy by dt, okay. Second subdivision, at what rate the area of the triangle formed by the ladder, wall and the floor is changing. So they are asking the rate of change of the triangle, area of the triangle OAB. That is the second subdivision. So anyway, with the use of the right angle triangle, first we have to form a equation. So x square plus y square equal to 17 square. That is the equation. It is a right angle triangle, okay. So first we can find out what is y, okay. So x is 8. So 8 square plus y square equal to 17 square. Y square equal to 17 square means 289, okay, minus 8 square is 64, change the side. So y square equal to, so 5 2 2 5. So y equal to 15, plus or minus bit, negative is not possible. So y equal to 15. So it is the value, okay. So now we need dy by dt. So differentiating 1 with respect to, okay, differentiating 1 with respect to t, okay. So it is the first subdivision. So 2x dx by dt plus 2y dy by dt equal to 0. Right hand side is a constant 0. So we can leave this 2. So put the known values and find out the unknown values. So we know x is 8 and dx by dt is 5 plus y is 15 into dy by dt equal to 0. So dy by dt equal to 5 8s are 40, okay. So if we change the side, we are getting minus. So minus 40 by 15. So cancel by 5. So 3 times. So here 8 times. So minus 8 by 3. I think what is the unit? Meter per second. So this minus sign indicates the height is decreasing. So you have to write the answer. The height is decreasing, okay, at the rate of 8 by 3 meter per second. That negative sign indicates that is decreasing. Second subdivision, our aim is to find out the rate of change of the area of this triangle. So area of the triangle, area delta equal to half into BH. So half into x into y. So differentiating again with respect to t, we get d delta by dt equal to half into, use product rule for the right hand side, x into dy by dx plus y into dx by dt. Sorry, x into dy by dt plus y into dx by dt. So use the values. Already we know that x is 8, y is 15, dx by dt is 5, dy by dt is minus 8 by 3. So put all the values in that right hand side. So we are getting 1 by 2 into, so 8 into, what is that? So dy by dt minus 8. So 8 into minus 8 minus 64 by, okay, 3 plus 15 into 5. So 15 into 5, 75. Okay. So 1 by 2 into minus 64 by 3 plus 75. Take the LCM. Okay. 1 by 2 into minus 64 plus what is that? 75 into 3. So we are getting 225. 225 by 3. Okay. So if we subtract, what we get? So minus, sorry, plus 161 by 6. 2 into 3, 6. So divided by 6. So 2 times. So remaining 441, 6 times. So remaining 5. So 5 means what is that? We can get 8 times. So 26.83. So put the units, meter square per second. Meter square per second. So that is the answer for the second subdivision. Question number 10 in the exercise 7.1. A police jeep approaching an orthogonal intersection from the northern direction is chasing a speeding car that has turned and moving straight east when the jeep is 0.6 km north of the intersection and the car is 0.8 km to the east. The police determine with their radar that the distance between them and the car is increasing at 20 km per hour. If the jeep is moving at 60 km per hour, okay, at that instant of measurement, what is the speed of the car? Okay, so my dear student, first draw the diagram for that one. So listen. So this is the orthogonal intersection. Orthogonal means perpendicular. So the jeep is traveling from the north. So first look at the direction, north, east, west, south. Okay. So from the north it is chasing. It is a point of intersection. So the car crosses the intersection and it is moving towards east. Okay. So it is in the eastern direction. It is from the northern direction. At that instant, the distance between the jeep and the intersection is 0.6 km. Okay, and the car and the intersection is 0.8 kilometers. Okay, so initially we got to assume the distance between the car and the intersection is x and the car and the jeep is y and the distance between them is z. Okay, so it is a right angle triangle. We can get the equation x square plus y square equal to z square. And also observe what are the informations given. The distance between the jeep and the car is increasing at a rate of 20. So dz by dt is given as 20 km per hour. Okay. Okay. And so the jeep is moving at 60 km. So moving at the 60 km. Okay. So we are measuring in the opposite direction. That's why we are putting minus sign. Okay, so towards intersection it is 60 km per hour, but we are measuring in the opposite direction. That's why we are putting minus sign. Okay, so initially from the given information we are getting the equation x square plus y square equal to z square, and given the, note down the informations given in the question. Okay, so differentiating with respect to t, so 2x dx by dt plus 2y dy by dt equal to 2z dz by dt. So my dear student, only x and y are given. Our aim is to find out z value. So using the equation 1, so 1 implies, so 0.6 square plus 0.8 square equal to z square. So 0.36 plus 0.64 equal to z square. So z square equal to 1, z is also 1. So find out z value initially. Now put the known values here. We can cancel this 2 because 2 is, take the 2 common and cancel it. We are getting x into, okay, x into dy by dx plus y into dy by ds z dy by dt equal to z into dz by dt. We need only dz by, sorry, dx by dt. So put the known values. So 0.8 into dx by dt plus y value is, sorry, x value is 0.6. So x value is 0.8, y value is 0.6. Look at the diagram. Okay, so 0.6 into y is minus 60 equal to z value is 1. So 1 into anything the same value equal to 20. Okay, so now what is that? 0.8 dx by dt equal to, so what about the value? 20. Okay, so what is that value? 6 into 6, 36. I think 1 0 is cancelled. So 36, but minus, if we change the side, it becomes, or you can write one more step, minus 36 equal to 20. Okay, so 0.8 dx by dt equal to, okay, so 20 plus 36, 56. If you want, we can cancel. So what is that? So dx by dt equal to, okay, 56 by 0.8. So 1 time, 7 time. So it is nothing but 70 because denominator 0.1. So it is 1 by 10. It goes to the numerator. So 70 kilometer per second. That is the answer for the speed of the car. The speed of the car is 70 kilometer per second.